Good morning, my dear children. Today we are discussing about the lesson number 2, P block elements. 1. The topic is carbon monoxide, preparation of carbon monoxide, and what are the properties of carbon monoxide, and some of the chemical reactions of carbon monoxide, and about the structure of carbon monoxide, and one more point, what are the uses of carbon monoxide, especially this area. One of the very important question is Fischer-Tropsch synthesis, one of the reactions. Carbon monoxide with the hydrogen, we get alkene, that is a saturated and unsaturated compound. Okay. And about one more important point is structure of carbon monoxide, it's a very important question. Okay. Please all of you take the note, we can be discussed one by one. Carbon monoxide. What is the formula of carbon monoxide? The formula of carbon monoxide is CO. That is, carbon element and oxygen element combines to form carbon monoxide. Previous class we discussed about that carbon monoxide exhibit. The carbon exhibit +2 oxidation state. Am I right? Preparation of carbon monoxide. Carbon combines with oxygen, that is carbon with limited amount of oxygen reacts to form carbon monoxide. We can write the equation carbon combines with oxygen, we get carbon monoxide. Here the reactant side 2 oxygen is there. How to change the product side to carbon monoxide? How much carbon is there? 2 carbon, make it clear, 2 carbon. Now the equation is balanced. How the industrial preparation of carbon monoxide, that is, carbon react with the air, we get carbon monoxide. But air having, what is the percentage of air? The air having 78% of nitrogen and 21% of oxygen, remaining the inert gas and other gas and water vapor, etc. Right? Here, this air also having nitrogen. Carbon react with the oxygen, that oxygen present in the air also having nitrogen, the both are combined to form carbon monoxide and also nitrogen. This we are saying that producer gas. What is a producer gas? That means the mixture of nitrogen, that is dinitrogen, and carbon monoxide is called producer gas. Okay. What is a producer gas? The mixture of nitrogen, mixture of dinitrogen. Dinitrogen means N2. The mixture of dinitrogen and carbon monoxide is called producer gas. Okay. Here, how can you write the equation? First, you have to write carbon combines with oxygen. Here, nitrogen also having. How to write nitrogen? That is dinitrogen. That is air. Am I right? Air means the maximum percentage of air is there is about that 78% of nitrogen and 21% of oxygen. So we are comparing right here. Okay. So C plus O2 and also nitrogen, that is air, we get carbon combines with oxygen, we get carbon monoxide, and also we get dinitrogen. How can you balance the equation? The reactant side having 2 oxygen, but the product side having only 1 oxygen. So make it the product side 2 oxygen. So now how much carbon is there? 2 carbon. So make it the reactant side 2 carbon. Now the equation is balanced. So the mixture of dinitrogen and carbon monoxide is called producer gas. Okay. Next about the producer gas is passed through a solution of copper 1 chloride under pressure, which gives the formation of CuCl, CO, and we get 2 molecules of water. What is the product is obtained? CuCl, there is a copper chloride, and CO, including CO, dot water molecules. That is 2 water molecules. Here we can say the name is copper 1 chloride dihydrate. Water can be written, say that dihydrate. 1 water means monohydrate. 2 water means dihydrate. 3 water means trihydrate. 4 water means tetrahydrate. 5 water means pentahydrate. Okay, so you have to say this is the rules for coordination chemistry. That lesson we can be learn, okay, about this one. Okay, anyhow, you have to write the formula CuCl, that is about the copper 1 chloride, carbon monoxide and 2 molecules of water. At reduced pressure, this solution releases the pure carbon monoxide. That is one method. And another one important method, carbon monoxide can be prepared from methanoic acid. Methanoic acid. That is one of an acid. You know that one, methanoic acid. What is the formula? HCOOH. Carbon monoxide is also prepared from methanoic acid by warming with concentrated sulfuric acid. Why we are adding concentrated sulfuric acid means concentrated sulfuric acid is one of the dehydrating agent. One of the dehydrating agent. What is the meaning of dehydrating agent? The removal of water molecules. Am I right? The removal of water molecules is called as a dehydrating agent. So you have to write the methanoic acid. Methanoic acid. Okay. What is the common name of methanoic acid? That is a formic acid. Okay, formic acid is other common name of methanoic acid. Formula is HCOOH on warming with sulfuric acid, H2SO4 we get. Here carbon combines with oxygen, we get carbon monoxide, and also hydrogen combines with OH to form water molecules along with sulfuric acid. Okay, so how can you write the equation? Formic acid, otherwise methanoic acid, on reacts with the sulfuric acid, we get carbon monoxide plus sulfuric acid dot H2O. Okay. Sulfuric acid dot H2O. We have to discuss about the properties of carbon monoxide. What are the properties of carbon monoxide? All of you know that one. It is one of the poisonous gas. Am I right? Carbon monoxide is one of the powerful poisonous gas. Anyhow, the first point. What is the first point? Carbon monoxide is a colorless gas, odorless gas, and also poisonous gas. Okay, which are the point here? One is about the colorless, odorless, and also poisonous gas. Second point, it is slightly soluble in water, not completely soluble in water. It is slightly miscible in water, soluble in water. It burns in air with a blue flame. Very, very, very important points. Carbon monoxide burns in air with a blue colored flame forming carbon dioxide. So, carbon monoxide on reacts with oxygen, we get carbon dioxide. What is the formula of carbon monoxide? CO plus O2 gives CO2. How can you balance the equation? The product side we are having 2 oxygen, the reactant side we have 3 oxygen. So how can you balance means come to the reactant side here. In the reactant side we can be changed to CO. Okay, 2CO plus O2 gives, we get CO to make it 2. The product side 2. Now the equation is balanced. And another one more reaction. What is a reaction means? Carbon monoxide is treated with chlorine in the presence of charcoal. Charcoal means we are saying carbon, am I right? This carbon monoxide on treatment with chlorine in the presence of charcoal to form one of the another one poisonous gas. one of the organic compounds, am I right? Poisonous gas. That is about the carbonyl chloride. Carbonyl chloride. What is the formula of carbonyl chloride? COCl2, which is also known as phosgene. Okay, very important question. Make it important. Okay. Carbon monoxide on reacts with chlorine, we get COCl2. That name is called carbonyl chloride. Otherwise, we can be say which is also known as phosgene. What is the use means? It is used in the synthesis of isocyanate, methyl isocyanate. Already we learned in the 11th grade. Okay, one of the use. Okay, phosgene. Okay. And also, we have to write the equation. What is the formula of carbon monoxide? CO on reacts with Cl2. The presence of charcoal, we get COCl2. Next one is about that very important. Already we learned in the first lesson. Carbon monoxide is act as a strong reducing agent. Carbon monoxide act as a strong reducing agent. Okay, that is on the elegant diagram. The applications of elegant diagram, we learned that on thoroughly. Carbon monoxide on reacts with iron oxide. The formula is Fe2O3. That is CO on reacts with Fe2O3. We get iron plus carbon dioxide. Iron plus carbon dioxide. How much iron is there? 2 iron. So the product should make it 2 iron here. Next about how much oxygen is there here. 3 plus 1, 4. So if you have make it in the reactant side 3 carbon monoxide means the product should also make it be converted into 3 carbon dioxide. Now the equation is balanced. Next about what about carbon monoxide on reacts with hydrogen? So important question. What about carbon monoxide on reacts with hydrogen? Carbon monoxide on reacts with hydrogen under high temperature and pressure. Very, very important point. Under high temperature. This is carbon monoxide on reacts with the hydrogen. Under high temperature and pressure, we get one of the gas called synthetic gas gives. One of the product is called methanol. Okay, methanol. What is the formula of methanol? CH3OH. Formula for methanol. Okay, otherwise the common name is methyl alcohol. Okay, methanol. Common name is methyl alcohol. Next, in oxo process, that means ethene. Ethene is common name is ethylene. Am I right? Ethene. What is the formula for ethene? C2. What is the formula of ethene? C2H4. Am I right? C2H4. What is the general formula? For alkene, general formula CnH2n. Okay, in ethene, on reacts with carbon monoxide in the presence of hydrogen, we get one of a compound called propanol. Propanol. Okay, propanol means CHO compound. Okay. Anyhow, we have to write the equation. Carbon monoxide. What is the formula of carbon monoxide? CO on reacts with ethene formula C2H4. Otherwise, we can be written as R CH2 double bond CH2 in the presence of hydrogen. That is, we can be right dihydrogen H2. So here, the hydrogen is breaking. This hydrogen is breaking here. And one of the hydrogen is attached to the CH2 group, and another one hydrogen is attached to the CO, carbon monoxide. Can you understand, my dear children? Here H2 can be split up into one hydrogen part is attachment to the CH2 group, and another one hydrogen atom is attachment to the CO group. So what is the product is obtained? CH2, when we are adding one hydrogen, we get CH3, and the double bond is converted into single bond, that is CH2, and we get CHO. What is the name of the compound? Can you say? What's the name of the compound? CH3, CH2, CH. What's the name of the compound? How much carbon is there? 1, 2, 3. 3 carbon is there. So, what is the root word of three carbon, one carbon root word is meth, two carbon root word is eth, three carbon root word is prop. Am I right? Prop. Here all having the single bond, so you have to write the ANE. Am I right? Then here the functional group is CHO. What is a functional group? CHO. So CHO means we have to write the suffix is AL. Am I right? AL. So what is the name? Here E is dropped. So what is the name? Propanol. What is the name of the compound? Propanol. Next one is a very important question. Fischer-Tropsch synthesis. One of the very, very important question. Fischer-Tropsch synthesis. Carbon monoxide reacts with the hydrogen, and also the pressure is less than 50 atmospheric pressure. Here we are using one of the metal catalyst as a catalyst. What's the temperature we are applying here means 500 to 700 Kelvin. So first one, carbon monoxide reacts with the hydrogen. Here we are giving the pressure. Pressure is less than 50 atmospheric. Okay, atmospheric pressure. We are using one catalyst that is about the metal catalyst. And we are applying one of the temperature is about, what is the temperature here? 500 to 700 Kelvin. We get saturated and unsaturated hydrocarbons. Which are the products is obtained here? Saturated and unsaturated hydrocarbons. Okay. So we have to write a equation. Before that, what is the meaning of saturated and what is the meaning of unsaturated? Here, one of an organic compound having only single bond, we are saying saturated compounds. Okay, saturated. For example, alkane. The general formula of alkane is CnH2n plus 2. For example, N is equal to 1. What is the name? N is equal to 1. C into 1, H2 into 1 plus 2. What is that one? CH2 plus 2. What is that one? CH4. What is CH4? Methane. Suppose we are writing N is equal to 2. What is the formula? When you are applying C2 H2 into 2 plus 2. C2 H4 plus 2. C2 H6. So, methane, ethane, propane, butane, pentane. These are all what? Alkane. What is the general formula? CnH2n plus 2. Am I right? These are saturated. What is about the unsaturated hydrocarbon? Unsaturated hydrocarbon. That is, a compound must contain either maybe double bond or triple bond. Maybe double bond or triple bond. So how can you write here? Can you say the example? Anyone example? Double bond or triple bond? Double bond. We can take the double bond. That means alkene. Okay, alkene. 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 What is the general formula? CnH2n. Am I right? CnH2n. Okay. N is equal to 2. How can you write N is equal to C2H2 into 2? We get C2H4 alkene. This already we learned in the 10th grade. Am I right? We are thoroughly learned in the 10th grade. These are all everything in our 10th standard portion. Okay. How to recall this on this area. Okay. Anyhow, we have to write the equation. How can you write the equation? Carbon monoxide reacts with hydrogen. Carbon monoxide reacts with hydrogen. What is our expected product here? Here we are using one number. What is the number means? N molecules of carbon monoxide. N molecules of carbon monoxide reacts with 2N plus 1 hydrogen. 2N plus 1 hydrogen, we get, what is the product? CnH2n plus 2 plus n molecules of water. What is the product is obtained? CnH2n plus 2 plus NH2O. Here, what is about the CnH2n plus 2? What is that one? Alkane. Can you say some alkane name? One is methane, ethane, propane, butane, pentane, etc. Am I right? What is the formula of methane? CH4. What is the formula of ethane? C2H6. Otherwise, CH3, CH3. Okay. Next about carbon monoxide reacts with hydrogen. We get CnH2n plus n molecules of water. Here also the same equation we are applying here. We are taking n molecules of carbon monoxide and also 2n molecules of hydrogen. N molecules of carbon monoxide and also 2n molecules of hydrogen. We get CnH2n plus NH2O. What is CnH2n? Alkene. Alkene formula. Okay. Next about carbon monoxide forms numerous complex compound. Some of the numerous complex compound with the transition metal. Okay. With transition metals means D block elements. One of the transition metal D block elements in which the transition metal must be in a zero oxidation state. These compounds are obtained by heating with the metal with the carbon monoxide. For example, we learned in the first lesson. Anybody remember that one? The first lesson, Mons process. Anybody remember that one? Which product is obtained by the Mons process? NiCO 4 times. Am I right? NiCO 4 times. What is that one? What is the name of that compound? Anybody remember? Nickel tetracarbonyl. Mons process, we learned that one. The refining of nickel. Mons process for the refining nickel, we learned that one. Am I right? Here also same compound formula we are using here. Nickel tetracarbonyl. Nickel, that is Ni. Tetra means 4. Am I right? Tetra, I already told that. Mono, that means single one number. Am I right? A di means 2, 3, tetra, 4. Am I right? Penta, 5, hexa, 6. Am I right? Yes or no? NiCO 4 times. What is the name of the compound? Nickel tetracarbonyl, one of the complex compound. And another one example I am taking. Iron pentacarbonyl. That is 5. Am I right? FeCO 5 times. FeCO 5 times. Another one compound I am taking. Chromium hexacarbonyl. Hexa means 6. So chromium means CrCO 6 times. These are some of the complex. Okay. So we have to learn this area. Next about the important area. Already we learned thoroughly about the structure of carbon monoxide. Already we learned thoroughly. Just once again we are recalling. Am I right? What is the structure of carbon monoxide? Carbon monoxide have a linear structure. Linear structure means we are simply saying straight chain. Am I right? Straight chain structure. The carbon monoxide, there are 3 electron pairs are shared between carbon and oxygen. 3 electron pairs are shared between carbon and hydrogen. Okay, this explained. We are explained in the 11th grade. Am I right? 11th grade about the molecular orbital theory. The molecular orbital theory already we discussed that one. Anyhow, what is the bond distance of carbon and oxygen? Bond distance, bond length. Otherwise, we can say the bond distance of carbon and oxygen is 1.128 Armstrong. Am I right? Here, the carbon having many resonance hybrid. Many resonance hybrid. Okay, but we are writing only 2 or 3 forms. That is a canonical form. That means, what is about the resonance? Resonance means nothing but one molecular structure we can be written as in different forms. Okay, for carbon monoxide in our textbook we wrote in a 3 form. Okay, here have not 3 form, but we have many forms, but we are taking some 3 form. Okay. How can you draw this carbon monoxide structure means? First you have to write carbon, Next, give one space and write one oxygen. I'm right. Anyhow, this carbon and oxygen having at least having one connection. Am I right? One small connection that we are saying about that bond. Am I right? One bond means there are must two electron. Yes or no? Two electron is one bond. This is one possibility. We have to write one gives like that. We have carbon, oxygen. We are using double bond. Again, we are giving one gives carbon, oxygen having three bonds. Okay. First, we are writing one bond. Next, we are writing two bond. Next, we are three bond. Okay. Suppose one bond having means give the oxygen 6 electrons. 6 electrons. This is a condition. Okay. This is the condition already we learned. And the carbon also, I will explain the next step. Try to understand. I will explain the next step. First, before that, you have to try to understand. Okay. One bond having means oxygen must occupy 6 electrons. Okay. That is carbon also having 2 electrons. Okay. Next, double bond having means oxygen you must give 4 electrons. Okay. Carbon also having 2 electrons. Can you understand? Triple bond having means oxygen having 2 electrons. Okay, carbon also having 2 electrons. Okay, can you understand? Try to understand the concept. First one, single bond means 6 electron. Okay, oxygen, I'm speaking about the oxygen. Single bond having means oxygen you can be arranged 6 electron. Suppose carbon double bond oxygen means oxygen having 4 electron. Suppose carbon triple bond oxygen having means oxygen having 2 electrons. Okay, otherwise you have to for carbon you have to fill two electrons. Okay, then first one, carbon having plus charge, oxygen having minus charge. Second step, oxygen having no charge, carbon also having no charge. The third one, carbon having the negative charge and having the positive charge. Okay, next I am going to explain how we can draw the structure. I will explain there. Okay, my dear children, first we have to write the electronic atomic number of carbon. What is the atomic number of carbon? Atomic number of carbon is equal to 6. Am I right? First shell we can be accommodate 2 electrons. Second shell 4 electron. Can you understand me? Second one, oxygen, the atomic number of oxygen is equal to 8. The first shell we can be accommodate 2 electron. The second shell we can be accommodate 6 electron. Am I right? So, what is the valence electron of carbon? The valence electron of carbon is 4. What is the valence electron of oxygen? The oxygen is about 6. So, 6 plus 4 is equal to total how much valence electron is present there? 10 valence electron is present there. Yes or no? So, okay, 10 electron is present there. 10 valence electron is present there. So, first we have to write the element. Which are the element having carbon monoxide, carbon and oxygen. Okay, in between carbon and oxygen we are make it a single bond like that. Suppose we are making a single bond means for one single bond we need 2 electrons. Am I right? For one single bond means we need 2 electrons. So how much valence electron having carbon monoxide? How much valence electron? That is carbon having 4 electron, oxygen having 6 electron, total 10 electrons having. Yes or no? Out of 10, we are making the bond means 2 electron over. Yes or no? So, okay, 10 minus 2. How much electron remaining having? 8 electrons. These 8 electrons, first you have to occupy to the oxygen. Already I told that they are having single bond means we must give how much electron? 6 electron. Am I right? So, oxygen I am giving 6 electron. 1, 2, 3, 4, 5, 6. That is one side 2 electron, next side 2 electron, next one side 2 electron. Am I right? Next one side 2 electron. That's the rule. Am I right? So 6 electrons, 1, 2, 3, 4, 5, 6. 6 electrons is over for the oxygen. What's the remaining? Remaining 2. Am I right? And the 2 electrons we are give to carbon. Can you understand, my dear children? I told that the valence electron for carbon and oxygen is 10. That is, carbon is 4 and oxygen is 6. 4 plus 6 is equal to 10. Yes or no? 10 electron having. I am making one bond here in between carbon and oxygen. So 1 bond means we need 2 electrons. So 10 minus 2 is over. Remaining we have 8. Out of the 8, I give 6 electron to the oxygen because the reason is here having single bonds. Here having single bond means we give only 6 electron. Remaining having 2 electron that I am giving to carbon. So we can be count the electron. Oxygen having 6 electron and including the bond having 2 electrons. So oxygen having 8 electrons, okay, as is follow the inert gas configuration. Am I right? So anyhow, we are discussing. Now we can be count the electrons up about the oxygen. Okay, I'm breaking here, a small break like that. I'm breaking here. Please now you count the number of electron in oxygen. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Here also having this electron is common to carbon and oxygen. So we are counting this one also. So oxygen having 7 electron, but outermost oxygen having only 6 electron. Here having 7 electron, extra electron having, additional electron having. That means we give the charge is minus. The charge is minus. Okay. Next we have to count the carbon. How much electron having carbon? Outermost shell having 4 electron. Here having 1, 2, 3. Here having shortage of electrons. Am I right? Having shortage, that is carbon donate electron, so gives a positive charge like that. Like this one we can be give the charge. And one more method you have to find the charge also. Already we thorough in 11th standard. Once again I will explain. Okay, that we learn the charge of one a particular molecule, not an element. We not learn the charge of a particular element. We learn the particular molecule. Am I right? Anyhow, once again I explain you. Second step we have to give the charge like that. Here, come to the above diagram. First, we have to give that one of the arrow mark. Am I right? That's the movement of electron. Here, this minus charge, that is first form, carbon single bond oxygen having the first form. This minus, okay, here having 2 electrons. These 2 electrons come to here. So the double bond is converted into single bond. Am I right? So this minus and plus here, mutually here means we get the losing the charge. That is one concept. So now you count the number of electron present oxygen. Already 2 is coming and joining here. So remaining how much having? 4 electrons. Okay. Now it is correct. Yes or no? Next, the third one step also. This also the electrons. Electrons are coming here. Coming and joining here. So what happened here? Carbon having 2 electrons, but oxygen having also 2 electrons. Now we are counting means carbon having more electrons. As we are comparing carbon having, I think that carbon having how much electron? 1, 2, 3, 4, 5 electron. As per the concept, carbon having must contain 4 electron. But based on this concept, we are separating here means here 1, 2, 3, 4, 5 means carbon have how much electron? 5 electron. That means extra electron having. So carbon gain on electrons. Gain means negative charge. Am I right? XX electron. Am I right? Extra electrons. When we are counting to the oxygen, they are having 1, 2, 3, 4, 5 only having. Oxygen outermost shell having 6 electron, but here having 5. That is loss of electron. That means electron give. That means charge is plus charge. Am I right? So next we have to count how the charge. That is very important for find out in the charge. Okay, very important. So let us we can be find the charge. Once again we can be find the charge. Already we learn about the molecule. Okay, molecule charge. Okay, for entire molecule only we find the charge. Here having each element you have to find the charge. Each element, okay, each element, for example, carbon monoxide. I am taking carbon monoxide. Carbon, single bond oxygen. 1, 2, 3, 4, 5, 6. Here also having 2 electrons. Am I right? So we are having what is the charge? We have to find out that one. Charge also we can be find out. Okay, without charge we have to find. Okay, first one carbon. You don't forget what is the formula. Don't forget that. Please write the formula there. Valence electron minus lone pair of electron. Valence electron can be written as VE. VE denotes means valence electron. Okay, minus lone pair LP. LP means lone pair minus bond pair BP. BP means bond pair divided by 2. Okay, already we have another one formula. Okay, there is not this one. Okay, this is here another one formula. Valence electron minus lone pair of electron minus bond pair divided by 2. This is one method. Okay, Simply find out. Okay, we have number of method for finding the charge. Okay, but that is not this, like we are separating another one form. Okay, here first one, we have to find the charge of carbon. What is the formula? Here first formula is valence electron. What is the valence electron of carbon? Valence electron of carbon is 4, because atom number is 6. Am I right? So valence electron minus lone pair of electron. How much lone pair of electron is here having? Carbon 2. Okay, am I right? 2 minus. Next, what is the next one? Bond pair. Bond pair means carbon and oxygen having one bond pair. Am I right? One bond means we need 2 electrons. One bond means we need how much electron? 2 electron. 2 divided by, as per the formula, 2. Okay. So what is our answer? 4 minus 2. Am I right? 4 minus 2, we get 2 minus, here 2 by 2 is equal to, we can be written as 1. Am I right? So 2 minus 1 is equal to, sorry, 2 minus 1 is equal to 1. Am I right? 2 minus 1 is equal to 1. So what is our answer for the carbon? What is the answer for the carbon? Plus 1. So you have plus charge. Okay, not minus charge. Plus. So plus, we are giving the plus. Yes or no? Next one. We have to find out the oxygen charge. As per the textbook, we have the negative charge. We have to find out what is the charge of oxygen. What is the valence electrons of oxygen? Valence electron of oxygen. That is, we know that one, 6 minus number of bond pair, number of lone pair. How much number of lone pair having oxygen? 1 pair, 2 pair, 3 pair. Am I right? So we can be right. 3 pair means how much electron? 6 electron minus. Then have to write bond pair. How much bond pair they're having? Only 1 bond pair. 1 bond pair means 2 electrons. 2 by 2. Am I right? So 6 minus 6 is equal to 0 minus, here 2 by 2 is equal to, right? So we get 1. So 1, 0 minus 1. So what is the answer here? Minus 1, right? So minus 1 is the charge. Minus is the charge. Okay. Can you write this one? Next one. Carbon double bond oxygen. Carbon double bond oxygen. Carbon having 2 electrons. Oxygen having how much electron? 4 electrons. How can you find out this molecule for each element? This molecule for each element. Okay, first one I am taking carbon. Carbon, that here, what is the valence electron of carbon? 4 minus, what is the lone pair of carbon? That is about the 2, am I right? 2 minus, what is about the bond pair? Here having 2 bond pair, am I right? So 1 bond pair is 2 electron, 2 bond pair is 4 electron. 4 by 2, am I right? So 4 minus 2, we can return as 2 minus 4 by 2 is equal to 2, am I right? So 2 minus 2 is equal to 0. So for carbon, they have no charge. That is, we can be written as no charge. 0 means no charge, am I right? No charge. What about the oxygen? How much valence electron having oxygen? We all of you know that on valence electron. How much valence electron? Atomic number is 8. First shell we can be accommodate 2 electron remaining 6 electrons. So 6 is the valence electron for oxygen minus. Next one. What is about the lone pair of this oxygen? How much oxygen having? 1, 2, 3, 4. 4 minus, as per the bond pair. How much bond pair having? 1, 2. 2 means 1 bond, 2 electron. 2 bond means 4 electron. So 4 by 2. Am I right? So what's the answer? 6 minus 4 minus 2. Am I right? 4 minus 2 is equal to 2. 6 minus 4 is equal to 2. 2 minus 2 is equal to 0. Now the oxygen also carrying which charge? 0 charge. Am I right? Next one. The last form, carbon triple bond. I mean triple bond oxygen. How can you find out this one? Carbon also having 2 electrons. Oxygen also having 2 electrons. How can you find the charge for this compound? For example, I am taking carbon. What is the formula? Valence electron of carbon is how much? 4 is the valence electron. 4 minus a lone pair of oxygen here having 2 electron, 2 minus, what is about the bond pair? Here having 3 bond pair, that is 3 into 2 is equal to 6 by 2. So we can 4 minus 2 minus 3, am I right? So 4 minus 2, what is the answer? 2 minus 3, so we get minus 1, am I right? What is the charge here? Minus 1. So first carbon having minus 1 charge. Next about for the oxygen we can be find out. What is about the oxygen? Here, first one, the valence electrons. Valence electron of oxygen is 6 minus lone pair of oxygen. They are having only 2 electrons. So make it 2 minus. What is about the bond pair having 6 electrons? Am I right? So 6 divided by 2. So what is the answer? 6 minus 2 minus 3. 6 minus 2 is equal to 4. 4 minus 3 is equal to 1. So 1 is the charge. Plus 1 is the charge. So we can be written as oxygen have plus charge. Next about we can be discuss about the uses of carbon monoxide. Here we are using water gas and producer gas. What is about the water gas? The mixture of hydrogen and carbon monoxide is called as a water gas. A mixture of hydrogen and carbon monoxide is called as a water gas. A mixture of carbon monoxide and nitrogen are called as a producer gas. Okay, these are all used in industrial fuel. Next, carbon monoxide is a good reducing agent. It also can be reduced many metal oxide to metal. Already we learned it. Am I right? Next, carbon monoxide is an important ligand and form a carbonyl compounds with the transition metal. That means already we learned the Fischer-Tropsch synthesis. We have the example. What are the examples there? Nickel tetracarbonyl. Am I right? What is the formula? NiCO 4 times. Okay. Here carbon monoxide is attached to the nickel. Am I right? And also carbon monoxide is attached to the iron. That is iron pentacarbonyl. Carbon monoxide is attached to the chromium, that is chromium hexacarbonyl. Here the carbon monoxide is attached to one of the metal that we are saying ligand. Okay, ligands, this is one of the ions are neutral molecules that are bonded to the central metal atom. Okay, this we can be explained in the coordination chemistry lesson. Okay, anyhow, carbon monoxide one of the important ligands and forms a carbonyl compounds with the transition metals. Okay, anyhow, today I am giving one of the very important questions. For that one means preparation of carbon monoxide. You have to write any one preparation, and also what happens carbon monoxide, that is CO reacts with the Cl2. Okay, CO reacts with the Cl2. The second question. Next, third question, Fischer-Tropsch synthesis. Very important question. Fischer-Tropsch synthesis and draw the electron dot structure of carbon monoxide and draw the electron dot structure, okay, dot structure for CO, carbon monoxide. Okay, thank you all of you. Thank you. Have a nice day.